Okay, so in this video we're discussing the complex conjugate theorem, and we saw this in the previous video, but basically it says that if we have a polynomial function with real number coefficients, so that means, you know, the a, the b, the c, whatever, they're all real numbers, that if a plus bi is a solution, then a minus bi is a solution. So I'll throw a couple quick examples out there. We'll do a problem, and then we'll talk about how the complex conjugate theorem is a part of that. And I want to look at this, and it also is the fact that if a minus bi is a solution, then a plus bi is also a solution. And so some real quick numbers. If we know that one solution is going to be 5 minus I, then 5 plus I is also a solution. And I said in the previous video, they come in pairs, okay? And the only difference between the pairs is one is a subtraction or a minus in front of the imaginary, and the other is a plus in front of the imaginary. So another quick one that kind of catches folks is if I is a solution, we have to think of it as 0 plus I. Then we can conclude that 0 minus I is also a solution. But we would just say I and negative I. We wouldn't put the 0 in front. Okay, so let's look. So here's our polynomial. And in the previous, check, get the right answer, all that good stuff. We said one of the first methods to look for is factoring. So that's the first thing I'm going to do. I may need to use a graphing calculator. I may not. I'm going to pull out the greatest common factor here, which is x squared. And I have x minus 3. And I notice that if I pull out a 4, I got a matching parentheses. So now the factoring by grouping works, which is awesome. That works. Now I'm going to set each one equal to 0 and solve. So this one's just 3, but this one, we get the negative 4, we take the square roots, x is going to equal 2i and negative 2i, and then the other solution is equal to 3. But notice here, with this one, we have our conjugate here. We have the negative and the positive. So the imaginary solutions come in pairs. The two i's are exactly the same. The only difference is one's got a plus and one's got a minus. And that's our complex conjugate theorem. That if I have one imaginary solution, the conjugate is also a solution. They come in pairs.